Section 3. Data Representation. Introduction. The characters, numbers, and other data types fed to a computer system, as well as the output from the computer, must be in a form that is usable by people. It is because of this that natural language symbols and decimal digits are used. This constitutes the external data representation. However, the representation of data inside a computer is different and must match the technology used by the computer to store and process data. This representation is known as the internal representation of data. As earlier read, internal representation of data by the computer makes use of only two symbols, 0 and 1. You will see how this is done for all the data types. Learning outcomes. At the end of this study session, you should be able to 1. Explain textual data. 2. Discuss numerical data. 3. Explain audio data. 4. Explain image data. 5. Discuss video data. Textual data. When any key on a keyboard is pressed, it needs to be converted to a binary number so that it can be processed by the computer and the typed character can appear on the screen. A code where each number represents a character can be used to convert text into binary. There are various codes used by the computer system to represent textual data. One of them is the ASCII character set that uses 7 binary digits to represent a character. What does ASCII stands for? It is the American Standard Code for Information Interchange. It was first used commercially in 1963, and despite the big changes in computers since then, it is still the basis of how English text is stored on computers. ASCII assigned a different pattern of binary digits to each of the characters, along with a few other control characters. Each pattern in ASCII is usually 7 binary digits but are stored in 8 binary digits. The first digit in each 8-bit pattern is a 0, meaning there are still only 128 possible patterns. The 0 at the front is just extra padding to make it up to 8 bits. Computers represent pieces of text with sequences of these patterns. For example, the word computers, all lowercase, would be, how would your name be represented? Numerical data. When numbers appear in text, they are represented using ASCII codes. However, if numbers are to be processed using arithmetic operations such as add, subtract, multiply, and divide, then a value must be assigned to them. All numerical data are converted to their binary equivalent, which carries the same values as the decimal equivalent. This binary representation of numbers is also known as base 2. Study the table below, which shows the binary equivalent of some numbers using only 7 binary digits. Notice that the ASCII code for the character 8 is different from the binary value of 8. When dealing with numerical data, the position of the digit plays a significant role. The rightmost bit is called the least significant digit, LSD, and the leftmost bit is the most significant digit, MSD. If the computer were to perform the arithmetic operation 4 plus 5 is equal to 9, it would look like this. Let us briefly look at the conversion of numerical data from binary to decimal and vice versa. Binary to decimal. To convert 10001011 base 2 to decimal, we do the following. Decimal to binary. To convert from decimal to binary is easier. You keep dividing the decimal number by 2 and record the remainder until you get a 0 quotient as shown below for converting 139 to binary. Audio data. In the previous study session, you learned that audio is a vibration. Typically, we are referring to vibrations of hair between approximately 20 Hz and 20,000 Hz. That means the hair is moving back and forth 20 to 20,000 times per second. If you measure that vibration and convert it to an electrical signal, say using a microphone, you will get an electrical signal with the voltage varying in the same waveform as the sound. An interesting question is, how do we represent audio information inside the computer? While many sound formats are far too complex to discuss here, e.g., the MP3 format. It is relatively easy to represent sound using the simple sound data format, something similar to the WAV file format. The variety of audio file types is due to the fact that there are quite a few approaches to compressing audio data and a number of different ways of packaging the data. However, some data needs to be converted into binary for computers to be able to process it. To do this, sound is captured, usually by a microphone, and then converted into a digital signal. An analog to digital converter will sample a sound wave at regular time intervals and record the value obtained. For example, a sound wave like what is shown in figure 5 can be sampled at each time sample point. The samples can then be converted to binary. They will be recorded to the nearest whole number shown in the table below. If we now plot back the time samples onto the same graph, it can be seen that the sound wave now looks different. This is because sampling does not take into account what the sound wave is doing in between each time sample. This means that the sound loses quality as data has been lost between the time samples. The way to increase the quality and store the sound at a quality closer to the original is to have more time samples that are closer together. This way, more detail about the sound can be collected, so when it is converted to digital and back to analog again, it does not lose as much quality. The frequency at which samples are taken is called the sample rate, and it is measured in Hz, Hz. 1 Hz is 1 sample per second. Most CD quality audio is sampled at 44,100 or 48,000 kHz. Video data. Let us now examine video data. There are different layers of video transmission and storage, each with its own set of formats to choose from. It is only in the last few years that the personal computer has been able to work with video data. Digital video files can now be stored on a computer file system and on different media, optical DVD, Blu-ray, or magnetic HDD. In addition to the physical format used by the storage or transmission medium, the stream of ones and zeros that is sent must be in a particular digital video encoding format, MPEG-2, MPEG-4, etc. Video data normally occurs as continuous analog signals. In order for a computer to process this video data, we must convert the analog signals to a non-continuous digital form. In the digital form, the video data can be stored as a series of bits on a hard disk or in computer memory. The process of converting a video signal to a digital bit stream is called analog to digital conversion, A/D conversion, or digitizing. A/D conversion occurs in 2 steps. Sampling captures data from the video stream. Quantizing converts each captured sample into a digital format. Each sample captured from the video stream is typically stored as a 16-bit integer. The rate at which samples are collected is called the sampling rate. The sampling rate is measured in the number of samples captured per second, samples per second, in bracket. For digital video, it is necessary to capture millions of samples per second. Quantizing converts the level of a video signal sample into a discrete binary value. This value approximates the level of the original video signal sample. The value is selected by comparing the video sample to a series of predefined threshold values. The value of the threshold closest to the amplitude of the sampled signal is used as the digital value. Summary. In study session 3, you have learned that 1. When any key on a keyboard is pressed, it needs to be converted into a binary number so that it can be processed by the computer and the typed character can appear on the screen. 2. When numbers appear in text, they are represented using ASCII codes. However, if numbers are to be processed using arithmetic operations such as add, subtract, multiply, and divide, then a value must be assigned to them. All numerical data are converted to their binary equivalent, which carries the same value as the decimal equivalent. This binary representation of numbers is also known as base 2. 3. An analog to digital converter will sample a sound wave at regular time intervals and record the value obtained. 4. The original and basic way of representing a digital colored image in a computer's memory is a bitmap. A bitmap is constituted of rows of pixels. Reduction of the words picture element. Each pixel has a particular value which determines its appearing color. This value is qualified by 3 numbers giving the composition of the color in the 3 primary colors red, green, and blue. This is the end of study section 3. Thanks for listening.